Okay, so yesterday we had done like Daniel Cell had like an introduction of electrochemistry, conversion of electricity to chemical energy, and then so what is EMF? How do you calculate EMF? Basically, difference of the potential on the cathode side versus anode side, cathode minus anode. So that's the overall EMF of the chemical cell. Um, we also saw that what does the electrode potential depend on? What all factors does electropotential depend on? Tell me.
Temperature, nature of the metal used, and concentration.
Concentration of the solute, right? So standard electrode potential, you're like obviously with as for different materials, you get different standard potentials. But you're fixing the temperature, you're fixing the concentration. We said temperature should be 25 degrees Celsius or 298 Kelvin. And we said concentration should be unit concentration, that is 1 mole per liter, 1 molar solution hona chahiye, right? So by keeping this constant, you're getting different potentials for different metals. So what, but you can't make sure that this is going to be the case all the time. So what is the relation between the E naught versus concentration, E naught versus temperature? So Nernst equation takes these into accounts and gives you a proper formula where you can plug whatever your criteria, whatever your conditions are, and then you can get the potential based on that. So according to Nernst equation, like suppose like, okay, for a half reaction, so we're still talking about single metal, like, okay, measure it against hydrogen. We've taken hydrogen to be default 0. So suppose you have reduction of metals, because we're always calculating reduction potentials only. So, reduction matlab, if we have M plus aqueous turning into M solid, this is reduction of the metal. Mn plus, let's say, n electrons gives M solid. Nernst said you can calculate iska potential as E m n plus 2m, with like this represents that it is the reduction potential क्योंकि reduce हो रहा है, is equal to E naught of n plus 2m, the standard reduction potential, minus RT by NF natural log concentration like of M upon concentration of Mn plus. So this is Nernst equation.
What is Mn plus?
So M is any metal, just that charge hai N plus, like Mg2 plus, Na plus. So I'll just discuss what all of these mean, and then you can note it down. Okay. So this is Nernst equation. For solids anyway, like if you're looking at metal deposit, this is going to be 1 anyway. We're not going to consider this. But yeah, that's the next step. But abhi ke liye, let's look at this. E is the EMF at the particular temperature T at a particular concentration. What is like E naught is the standard electrode potential. What about the rest of the things? So here R will be equal to
Ma'am, how do you define electrode potential? What does that mean?
What is electrode potential? Electrode potential is that, okay, so when you have a metal dipped in a solution of its own salt, like magnesium versus magnesium nitrate or zinc versus zinc sulfate, that way. Same metal, same salt. Then metal may you have neutral metal atoms. Solution may you have metal ions. So the metal atom have a tendency to lose electrons. So M will get converted to M plus, like there is oxidation also. And M plus, some ions will get deposited on this, they'll absorb the electrons and get converted, like reduction also happens. Now, depending on which metal it is, what their tendency is, if they're highly electropositive versus not very electropositive, both these processes kind of get settled into a equilibrium. So at equilibrium, whatever the charge is accumulating, whether it's a positive charge from metal, like from the reduction happening, or whether it's negative charge from the oxidation happening, that overall charge kind of creates a electric potential because there's a charge separation, there's charge difference being created. So that electrode potential is what we're talking about. Okay, so what is R in this equation?
Yes, constant. Yes, constant.
Yes. R is everywhere the same thing, universal gas constant. Okay, T.
Temperature.
Yes. Temperature in Kelvin always. Okay. N.
Number of electrons.
Number of electrons required for this reduction process. That depends on charge of the metal on RHS and LHS. Okay. Okay, F is
Faraday constant.
this is Faraday's constant. Yes. Faraday constant. This is another constant. So Faraday constant is defined as, have you guys done this? Like, have you come across this? No? Okay. So Faraday constant is defined as the charge on 1 mole of protons or electrons. Like single proton or a single electron will have a certain unit of charge, right? Same numerical value, minus for electron, plus for proton. So if you take 1 mole of it, whatever numerical you get, the number you get, that is Faraday's constant. This is equal to 96,500 Coulomb array. I'm just gonna write it over here. There's no place.
Nernst equation is only for half reactions.
We've just started it. You can apply this to oxidation reduction also. Like suppose you have a cathode and then you have like a Nernst equation for anode. You can get it for a cell by doing cathode minus anode. So we'll build upon it. You can apply this to different situations. So yeah, this is the total charge present on 1 mole of protons or 96,500 coulombs, Faraday constant. Okay. So you see that there's a lot of constant values, right? Like universal gas constant is a number, Faraday constant is a number. It's like a single number for all the conditions. If you fix temperature also at STP wala temperature, you'll get an easier way. Like if you want to get a formula where you only want dependency on concentration, you're able to maintain rest of the things. This can be modified into a different equation. So once you've noted this down and up to here, we'll modify it and see other cases. इसका भी वैल्यू लिख लेते हैं 8.314 हाँ 314 जूल पर कैलोरी हो गया? Anyone who's still right? ठीक है.
1 second. Done.
Okay, 2 points to consider here. यहाँ पे numerator में we took concentration of the solid metal, right? Like product side में जो भी है. What is the concentration of solids usually taken as, like active mass of solids? This will be equal to, like whenever you have something in the elemental state, उसका concentration
1.
1.
1, and others, as I've said, like we saw R and F are constants. So if we also take and at temperature equal to 298 Kelvin, and another thing is यहाँ पे natural logarithm है ना. So if you convert that into regular logarithm to the base 10 multiplied by 2.303 and all that, so there's a modified version that you can use for your regular calculations, which is electrode potential for any, or reduction potential for any metal will be equal to the standard reduction potential minus, so R and T, like we're putting all of that constant. So the number you get is 0.059 upon N times log of 1 upon Mn plus. So यहाँ पे the only variable is two variables essentially, which is the concentration of the solution that you're taking and the number of electrons involved in that reduction process. That's the only information you need. Plug the values direct, and then you can find the unknown thing. This is easier because concentrations, if you take it in terms of powers of 10, 0.1 m, 0.01 m, this calculation gets easier. So. Okay. Yeah, this is specifically at T equal to 298 Kelvin. If temperature is different, then you can't use this. Like you'll have to substitute for that. Now, how do you use this in order to find EMF of a cell? So Arya will be answering your question now.
What?
How do you use this equation, Nernst equation, to find EMF of a cell? So this is for a single electrode, right?
Yeah.
Yeah. So how do you find it for EMF of a cell? This is pretty easy.
You add both electrodes, so you get EMF. No, cathode minus like that. That
EMF of a cell is E cathode minus E anode. So you'll have like both oxidation half ka, reduction half ka. So standard cell potential minus. Then the logarithm side also will get modified. So I'll just like skip all of those and then like just tell you what the final result will be. Cell matlab you have like both sides of the equation, right? You have a reduction half and an oxidation half. Full reaction hona chahiye. So suppose our equation is this way. A plus B gives C plus D. Don't worry too much about the specifics, like one of them is getting oxidized, one of them is getting reduced. Then iska E cell will be equal to the E naught of that particular cell minus.
What is that? What is that? N plus.
N plus is the charge.
No, as in N stands for.
the number of electrons, like
Yeah.
yeah,
Yeah.
N is 2. Yeah. Okay, so when you have this same thing RT by NF, so half cell may we had product upon reactant, right? Here also will be the same thing, product upon reactant. So यहाँ पे the product will be concentration of C raised to the power C, concentration of T raised to the power D upon concentration of A raised to the power A, concentration of B raised to the power B. This is the most complicated form of Nernst equation, but this is not something you'll have to use because when we're looking at redox, two of these are going to be like solid metals, right? Like if you consider the zinc or copper ka half reaction, zinc is getting oxidized, so LHS may zinc is going to be solid metal, so that's going to get it's going to become 1. RHS may copper is getting reduced, so that's going to be solid metal. So yahan pe one of them is going to become 1. So essentially it's just products may whatever is in the aqueous state or reactant may whatever is in the aqueous state, that's what you'll have to consider in this situation. Yeah. Again, we'll give it the same treatment at 298 Kelvin. This is the more useful form of the reaction that you'll be going to apply in your numericals. So E cell will be equal to E naught cell minus 0.095 upon N into logarithm of this particular format of the products upon reactants.
Ma'am, 0.059, right?
I'm sorry, I said 59, but I wrote 95. Yeah. You can use this. I think like most of the times, either the half reaction wala or this is the thing you'll be using most of the times. We'll do a couple of questions based on this. Otherwise, it'll kind of be like an information overload. Okay, noted. Guys, if anyone's still writing, like stop me. Okay, so this question. Calculate the EMF of the cell at 25 degrees Celsius, so 298 Kelvin. So you don't have to, can just use the 0.059 directly. you're given in the form of cell representation, and you're given the E0 values. Can you solve this? Be careful of the signs here. यहाँ पे ion is getting reduced, but ion is getting oxidized, but here you get given the reduction potential. Actually, you don't have to worry about it because we're taking in the form of reduction potential only. Be like minus of minus.
We have to use the E cell is equal to E naught cell minus 0.05. That formula, right?
Yeah, you can use either one of, because the other half, the standard reduction potential you're taking is 0 anyway. So it won't make a difference whether you use the E cell wala formula or the half reaction.
Also, that N in the denominator of
Oh,
the
okay.
E cell, what does it mean? What
The same as
number of
number of electrons. यहाँ पे 2 plus to 0 जा रहा है, right? So oxidation reduction में कितने electrons exchange हो रहे हैं? 2 electrons in this case. N will be equal to 2. Kaveri, do you remember the cell representation, or do you need help with that?
No, I understood in class in school. So, one question. Hold on, my question. 1 second. Yeah, the N, it's number of electrons. So for Fe, it's 2, but then there are like 2 metals, right, in Daniel cells. So wouldn't there be like, oh, 2 electrons are transferring from the right? Okay.
It's always going to be like balanced. Redox, like you guys have done redox reaction last time, right? If one gains electrons, the other one will lose. The number will be the same. So
Also for log products by reactants, products and reactants, only ion we take.
yeah.
So like not for hydrogen, right?
Hydrogen will be 0 anyway.
So we have to use which, like, Nernst equation for this?
Products and reactants, right? Standard me, you're taking 1 molar concentration for hydrogen, like that's the standard. In this case, you're given the concentration of hydrogen, right? So you will consider that. You'll have to consider that.
Do we have to use Nernst equation in this?
Yes. There's no other way you can do it. You'll have to use Nernst.
So when we say cathode minus anode, E of cathode minus E of anode, usme the E, how do we find? That will be given, or?
So you have to find that only. You're given the standard values. E0 values are given here. E0, like reduction potential of Fe is given here. Reduction potential of hydrogen is given here. You don't have to go that far. Like we have the reaction, right? E cell, EMF of the cell is equal to E0 of the cell. E0 of the cell ke liye you have it for both cathode and the anode. So you're just going to use this.
Also products and reactants, what would the products be? Like, would it be Fe2 plus?
Can you build the reaction based on this?
So Fe plus 2 electrons gives, no, I don't know what I'm doing.
Converted to Fe2 plus,
Fe2 plus.
and then H plus is on the reactant side, getting converted to H2 gas. Balanced hona chahiye, so 2H plus. So this is your reaction. So this will be concentration of Fe2 plus divided by concentration of the H plus square. Smera has already solved it. Let me check it quickly. Logarithm ka, I hope, yeah, I don't think you would require it. Everything is in the power of 10. Yes, mil gaya. Okay. First step, if you guys have already completed it, can you tell me what you got E0 cell?
0.44.
0.44.
Very good. Kaveri, what happened? Aya?
Temperature Celsius only we have to use.
No, temperature is always converted to Kelvin. Like never use Celsius in any of the numericals, always converted to Kelvin. But you don't have to worry about the temperature. You can use this equation directly because you're given at 25 degrees Celsius, right? So just use this.
So it will be RT na, so उसमें T भी ली उसमें. Oh, अच्छा.
वो पूरा calculate करके ही है, like there's a shortcut. Yeah. So E0
So will it be plus 0.44 or minus?
So E0 reduction minus E0 oxidation, right? If you can identify cathode, anode from this, you can do it. Or since you're given the cell directly, you can do E0 right minus E0 left. Or E0 reduction minus E0 oxidation. This is like, I find this to be easier because it's for me, it's easy to identify reduction oxidation. So यहाँ पे reduction और cathode में क्या हो रहा है?
Right left, when we say, we mean how we represent the Daniel cell or the reaction?
Cell representation में right left. So right side is hydrogen, right? Or reduction, hydrogen is getting reduced. So hydrogen is 0 minus. Ion is getting oxidized. That is minus 0.44 is what we are given. So E0 cell is overall going to be plus 0.4.
How is it 0? How is hydrogen 0?
Because that's a standard. Like hydrogen is always considered 0 at STP conditions. And we are also given the value over here. You can see that E0 is 0.
Only for hydrogen.
Everything is measured against hydrogen. So that's, yeah. Arya, Sia, yes. Arya, units?
Volt.
Okay, yes. So we got our E0 upon N equal to 2. Then concentration of product, concentration of reactant, we just have to put it will be what 0.44 minus 0.059 divided by 2 into log of this.
Log of product ions by reactant ions means, like, in this case, what will it be?
Like Fe is in the product. So Fe is getting converted to Fe2 plus according to our cell over here. Ion is getting oxidized. Fe2, Fe2 plus. H plus is getting converted to H2. So our reactant is Fe and H plus. So Fe plus 2H plus. Product is Fe2 plus and H2. So product may we have H2 is elemental, so this is going to be 1. Iron is in aqueous state, so iska concentration use karna padega. So you'll have the whole thing. Log concentration of iron is given as 0.001. I'll write it as 10 power minus 3 divided by reactant elemental iron is going to be 1. So we just have to consider iska concentration. Stoichiometric coefficient 2 hai.
When it's elemental, then the concentration is always 1.
Solid, liquid, gas, pure substances is always 1. इसलिए even in equilibrium, wherever you had H2O, you'd always take it as 1 in the reaction. Only ions ka concentration is what you have to consider. Be 10 power minus 2. So you just need to solve it. It's all in like base 10. This is 10, so it gets pretty straightforward.
Is it ever like raised to something if there's like a stoichiometric coefficient?
Yeah, raised to 2 now. Oh yeah, it's 2. Good catch. Minus negative 2. Yeah.
Understood.
Okay, so you guys wanna go to the next part or you wanna do another question?
Can we do one more question?
One more? Okay, let me see. Equilibrium constant to discuss nahi kiya na. So we'll go to this one. Oh yeah, this is a good one. Okay, here it says write the Nernst equation, but since you're given E0 values of magnesium and copper, calculate the EMF. Oh, write the Nernst equation and EMF. Okay, fine. Yeah. Just do the first one, that's enough.
EMF matlab E cell.
Yes.
So that will give us the Nernst equation se only we find that out. No?
Just do this one, like the first one alone. Then will you guys be able to do it in a minute, 20 seconds? Try it. Start the new session with the new topic.
We don't have E naught.
You have it, no?
Oh, then.